lesson 4.7, we're going to talk about two different methods of solving linear equations. Both of them are dealing with using graphs. However, one, we will start solving it algebraically and check our answer with a graph. And the second approach will be solving the equation with a graph and checking it algebraically. The steps for solving linear equations graphically are stated here. You can pause and make note of that. And we'll go ahead and put one into action for you. So, solve 2x minus 5 equals 11 algebraically. So we need to solve this using algebra. So to solve, we're just going to solve for x, that means. So 2x minus 5 equals 1. I need to go ahead and get my variables on one side, constant term on the other, and solve for my single variable. So I have that x equals 3. Now, to do the next step, however, we want to try to check it graphically. So to check an equation graphically, I'm going to go ahead and I'm going to write the equation. The first step said write it in ax plus b equals 0 form. What this means is we're going to have the coefficient with the x, we're going to have a constant term, and that is going to equal 0. So my original statement, 2x minus 5 equals 1, I want to set it to equal 0. So this time I'm going to move the 1, and that's going to give me the result of 0, and 2x minus 5, and then we have another constant term, negative 1. So now my statement is 2x minus 6 equals 0. Now this statement, once I've put it into the ax plus b equals 0, I can now change this statement into a slope-intercept equation. To do that, I want to replace my 0 with a y. So my equation now will say y equals 2x minus 6. Now, when I have the equation in this form, I can go ahead and I can do as I did in the last lesson. I can find my y-intercept and I can find my slope. So let me just reveal the graph here. Maybe. I guess I didn't select it yet. Now we can reveal it. So on the graph, you're going to see if I graph the line y equals 2x minus 6, I'm going to go ahead and b means the beginning. I'm going to make my point on the negative 6 for my y-intercept. I'm going to go ahead and I'm going to apply my slope, which is 2. So I'm going to rise 2, run 1, and I'm going to and then I can connect those points. So rise 2, 1. Sorry, my stylus wasn't working very well there. Oh, there we go. When I connected the points, you will see the line that was created. And then I can go ahead and check that solution, because if it is true, I should have an x-intercept at 3. And you can see the x-intercept is 3, so the solution 3 is correct. So first, solving it algebraically means solving for that variable x. Then you're going to go ahead and put that into the ax plus b equals 0 form. When you do that, you can convert that into the slope-intercept form by replacing 0 with y. And then you can go ahead and graph it using the y-intercept, negative 6, and the slope, 2 over 1. So rise 2, run 1. In example 2, we're going to do it in just the opposite order. It says solve the equation graphically and then check your solution algebraically. So I'm going to go ahead and reveal the graph first. As I said, when we look at this equation, we want to make sure that we can put it in slope-intercept form to be able to graph it first. So we're going to change it to y equals mx plus b form. So we first have to, you'll see there is no y in this original equation, so we need to set it to 0 first. So 4/3 x plus 3 equals 2x. I want to set this to 0, so I want to subtract 2x from both sides. Now here's where many of you get in trouble. We have fractions, so I'm going to rewrite this. If I'm going to subtract fractions, I need both terms to be in fraction form. So I have a 4/3 x. I want to subtract 2x, so I need to put that in thirds as well. 2x would equal 6/3x. And then this is plus 3, and now we have equals 0. As I do that, I'm going to get 4 minus 6 is a negative 2/3 x plus 3 equals 0. Now I can change it into slope-intercept form by replacing the 0 with a y. Y equals negative 2/3 x plus 3. Now I'm going to start at my b term, which is positive 3, my constant term, and I'm going to make my y-intercept. Oh, that one was pretty close. Now I'm going to apply my slope, mx, so that is the coefficient to x, negative 2, 3. So negative 2 means I'm going to rise, actually go down 2, and then I'm going to run 3. 1, 2, 3. Sorry, wasn't very good there. And you can see my other point. Now I connect those points, and there is the graph of the line. We just solved it graphically. Now we want to check the solution algebraically. So when we check that solution, we're going to look and see where that graph appears to be crossing the x-intercept. And here you can see it appears to be happening past 3, past 4, and about halfway to 5. So we're going to say that the x-intercept is about at 9/2 from our line that we graphed. So to check that algebraically, we're going to substitute in then that x equals 9/2 into our original statement. So we would have 4/3 times 9/2 plus 3, plus sign doesn't want to make it, equals 2 times 9/2. When I go ahead and I multiply this, let's do some reducing. 3 goes into 3 once. 3 goes into 9 3 times. 2 goes into 2 once. 2 goes into 4 2 times. 2 times 3 is 6. So 6 plus 3. And then let's go ahead and multiply this side. 2 goes into 2 once. 2 goes into 2 once. Make my one a little bit better here. So equals 9. Is 6 plus 3 equals 9 a true statement? That is. So that means that that checks out correctly. Now, both of these are a little different approach. We've worked in a couple new steps, so you might need to go back and pause them and make sure that you understand and can put in your own words the steps to solving these equations with both approaches, how to solve it algebraically first and check it graphically, or how to solve it graphically and check it algebraically. The next example in your book is example 3 using a graphing calculator. and I will show you that in class with your laptops. So this is where we will finish lesson 4.7.